So this is my second video on upper and lower bounds. Make sure you watch the first one before you watch this one, provided that you're not confident on upper and lower bounds. If you are confident and you know what you're doing, then by all means. Alright, so here we go, upper and lower bounds. So what we're going to do in this video, we're going to apply it to some real life situations, sort of, and see how it works. So before I go ahead, let me explain this table to you. So what this table basically means is, depending on the operation you're doing, whether you're adding, subtracting, multiplying, or dividing, if you're adding two numbers and you want to get the maximum possible value or the upper bound of the numbers, then you need to add the upper bound of both numbers. And that's what you're going to see lots of UB and LB. So UB means upper bound and LB means lower bound. Okay. If you want to have the smallest possible number, then you need to find the lower bound of both numbers and add them together. If you're taking away, it's a similar sort of situation, but with one slight twist to it. So if you're taking away, you want to have the upper bound or the maximum possible number, then you take the upper bound of your first number and obviously take away the smallest possible number you can take away from it, which is the lower bound. And if you want to minimize on things or you want to find a lower bound, then you take the lower bound of the first number and take away the biggest possible value of the second number from it, and that will give you the smallest value. When multiplying, you want to multiply your upper bound times your upper bound to get a maximum value, and you want to multiply your lower bound times your lower bound to get the minimum value or the lower bound value. And when dividing, slight twist again, you want to take your upper bound and divide your lower bound into it. And if you want to get your minimum value, you take your lower bound and you divide your upper bound into it. Okay, so it's important to remember this table before we proceed. If you don't think you can remember it, pause the video here and copy it down quickly on a piece of paper. I'll be referring to it quite a lot. So let's go. So here we have a rectangle, and I'm going to say that this rectangle represents, I don't know, someone's, I don't know, maybe a piece of paper. Maybe a piece of paper. So the measurements on this piece of paper is 9 centimeters to the nearest centimeter and 5 centimeters to the nearest centimeter. Bearing in mind, I just said the nearest centimeter. So if I want the nearest centimeter, it means that I'm looking at the unit value of 9 and the unit value of 5. So I'm looking at 1. So I'm going to take my 1 and I'm going to divide it by 2. So this gives me 0.5. And now it means that for my 9 centimeters, I'll write it over here. So for my 9 centimeters, it means that my upper bound is 9.5 and my lower bound is 8.5. Same thing for the 5 centimeters. My upper bound is 5.5 and my lower bound is 4.5. Alright, so now that I've got my upper and lower bound, I can now calculate. What I need to find out is the limits of accuracy. Sometimes the exam question might ask you for the limits of accuracy, or they might say find the maximum possible area of this rectangle or the minimum possible area. And you can remember from our table that we just did, if I want the maximum possible area, then I need to multiply the maximum length by the maximum width, or the upper bound of both. So we're going to look at 9.5 times 5.5. Yep, and this gives us 52.25 centimeter square, as its area we're finding. And the minimum possible area obviously means we multiply the two minimum values, so 8.5 0.5 times 4.5 to get the minimum possible area, and this gives us 38.25 centimeter square. All right, so that was the first one. First one was a nice and easy one. Let's move on. So here on this second rectangle, I'll put some measurements in. Okay, so here I've got 8.4 and 4.5 centimeters for this one. And we want to find the maximum possible area and the minimum possible area, and we have to round to 1 decimal place. Well, not the answer, but we need to find the upper and lower bound to 1 decimal place. So 1 decimal place means we're here, so we're looking to half the number 0.1. So we need to find, maybe I should do it in the corner over here. So 0.1, we need to find half of that, which gives us 0.05. Okay, so once we find half of it, we can now find our upper and lower bound. So here we go. So 8.4 there, and we add 0.05 to it, so we get 8.45 for our upper bound, and we take away 0.05 from it, so we get 8.35 for our lower bound there. Do the same thing for 4.5. So 4.5 for our upper bound, we add 0.05, so we get 4.55, and for our lower bound we get 4.45 for our lower bound there. Okay, so now we've got our upper and lower bound for both the length and width, and we have it to 1 decimal place as was asked in the question. We can now go ahead and find the maximum area and the minimum area. So maximum area would be taking the upper bound of the length and multiplying it by the upper bound of the width. So two big numbers give you an even bigger number. So 8.45, we multiply that by 4.55, which tells us that our maximum area would be 38.45, if I round it to 2 decimal places, centimeters square. I have rounded it because it was 4475, but we'll round it to 2 decimal places. Okay, so now our minimum area would be multiplying the two smaller values, the two minimum values here, or the two lower bounds. So this will give us 8.35 times 4.45 there. Once we multiply those, we get 37.16 to 2 decimal places centimeter square. All right, so that's basically how you maximize and minimize area. Let's give you a chance to have a go. So on this question here, I'm going to say the length is 18 centimeters. I'm going to say the width is 7.8 centimeters. And what I want you to do is pause this video and find the maximum area and the minimum area, but find your upper bounds and your lower bound to 2 significant figures. So 2 significant figures. You pause the video here and have a go, and then I'll work it out in about 10 seconds. Okay, I hope you did all right. So 2 significant figures. Let's start with the length. This is my first significant figure. This is my second significant figure. So my second significant figure in this number is a unit. It is 1. So half of 1 is a half. So for 18 then, my upper bound would be 18.5 or 18.5, and my lower bound would be 17.5. For my second number, my second significant figure, because remember I want two significant figures, my second significant figure is in this position, which is 0.1. So I need to find half of 0.1, which is 0.05. So that means that my 7.8, my upper and lower bounds will be 7.85 and 7.75. All right, so if you had those numbers, then you're going to get the answer. I'm not going to work it out. I'm just going to jump straight to your maximum and minimum area. Okay, so I hope that those were the two answers that you got after you paused the video. All right, let's make ourselves a final challenge here. So here we have a situation where a rectangle is given and the area is already given to the nearest 10 square meters. To the nearest 10 square meters. One of the length would be 16 to the nearest meter. What we need to do in this question is to find the other length, to find the upper bound and the lower bound of the other length. Okay, so we want the upper and lower bound of the other length. Well, let's get to work. The area has already been rounded to the nearest 10 meters or 10 meters square. This number here is in the place of the nearest 10 meters square. So we're looking at 10 in any case. It's a tens number, so we're looking at 10. So half of 10 is going to give us 5, which basically means that the 350 that we now have, the upper bound of it would have been 355, and the lower bound of it would be 345. Also, we've been given one of the lengths, which is 16, and it's already been rounded to the nearest meter. So the units is in the nearest meter there. So now it means that our 16, the upper bound of it would have been 16.5, because we would have halved 1, wouldn't we? And then we've add on a half and take away a half. So 15.5 would be the lower bound. All right, so let's get to work. You already know that if I'm given the area, we know that it was length times width that gave us that area. We've already been given the area and one length. So if we need to find the other length, we need to do an inverse operation. So we need to divide. So I'm going to say therefore that the missing length, I'm going to say, or let me call it the missing length. So the missing length, call it the missing length. I'm going to call that missing length A, and I'm going to find the maximum, so A max I'm going to call it. Now you remember our table I asked you to copy? In this case we need to divide. And so if we want to maximize our value, then we need to divide a maximum by a minimum. So we need the maximum area, 355, and we need to divide the minimum length of 15.5, and that will give us our maximum value. And this maximum value is 22.9 meters. Okay, so that's the maximum. Now we're going to find the missing length, a minimum. We call it the minimum length. Well, we do the opposite of what we've just done here. To find the minimum, go back to that table and have a look again. But to get a minimum length, we need the minimum area of 345, and we need to divide it by the maximum length of 16.5. And this will give us 20.9. So there we have it, guys. That is basically what in this day and age would be called an A-star question. Pretty soon GCSE will change, so it wouldn't be that anymore. But that's a typical question that you're going to get. All right, now I think you've basically got this now, and you understand it well, or at least I hope you do. Time for you to practice some questions. I'm not going to give you any more questions on here to practice, but you go to any textbook and have a go. All right, hope this was good, hope it was enjoyable, and I hope you've learned something.